Hello everyone! It's that time of the week again when we do some live streaming. Sorry, I'm going to rearrange my windows a little bit like that. Okay, so we're ready to go. Last week we did a bunch of stuff. Still working on the asteroid game. And let's just take a look what it looks like. And unless I'm misremembering, we can actually run this in full screen. Right, yeah, we can. So you got this. First week we set up all the physics stuff, so that would work. And we got that going and generating these asteroids as well. It's running really slow now because of reasons like. But disregard that. The game works. It runs. We can fly around with our little ship here. And last week, which was the second week we've been working on this game, we added you can slice asteroids like this. Now the obvious thing you notice is that when I slice something, let's do it again. Like, look at this asteroid here. It's got a point here, 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 and here, and so on. So if I slice it like this, all these points stay in the position they were before. So that's all cool. But the thing we never got around to, we started on it, but we never managed to finish it, is to add in vertices for these points here. Because we had some, Box2D is really picky about the order of the vertices, so they need to be in counterclockwise order. So that's the first thing we're going to solve today to make like the actual slicing thing work. And I have actually had some time to think about how I want to do it, so I have a plan for how to attack this. And so because it's not adding in extra vertices, it ends up with like this guy right here being a single vertex polygon, which is hard. It's not a very good polygon unless it actually has many corners. And this guy over here turns into a 2-corner or 2-vertex polygon, which is also a pretty crappy polygon. It's more like a line. So the physics engine gets upset with us, and I can respect that. So I have some other projects up here. Close that, and we're gonna take a look at the laser. So this is the function we need to focus on. It's the split function. This will take, last week we wrote the code to actually figure out which fixture we're hitting, which is essentially which asteroid basically we're hitting, where the laser enters it and where the laser exits from it. So that's all good. Like that's really all we need math-wise to set this up. Excuse me, 1 second. There we go. So we're gonna make this work now. So the thing I was thinking about last week, or we can let's go over this code first. So it gives us the fixture, it gives us the entry point and the exit point. I added this little check right here to make sure that the fixture we get is in fact a polygon shape, because right now we have everything is polygon shapes except for one thing, and that's the player shape, which is a circle. So it won't actually try to split the circle because it needs to be a polygon shape. Maybe we can split circles some other day, but not today. And I mean, we don't want to split our own ship anyway. Let's move on. So we got the body here, which is in Box2D, objects are comprised of like the body is the outermost layer of something. It's like so say you have like a physics object is going to be a body, And then that body is comprised of fixtures. All the fixtures I have in this game right now, or all the bodies I have in this game right now, have just one fixture. So that's fine, but we need the body for some stuff. We figure out the entry point and the exit point in the local coordinate system of the asteroid, because the asteroid is spinning, right? So when it spawns, the coordinate system of the asteroid is kind of sort of the same as the real world, but it's spinning and it's moving around. So we need to move those points into the local coordinate system of the asteroid. And that's what we need the body for. Then we figure out which angle, the angle of the split is happening along the asteroid. By subtracting these two vertices, then we get an angle in the local coordinate space of the asteroid. And then we normalize this to make sure that it's, yeah, we want a directional vector. We don't want a size on that vector, essentially. And if you have questions about any of this, just shout and I'll go back and I'll do it again. Then we figure out the center point of the split. This sounds kind of complicated. It really isn't. So we add together the entry point and the exit point, and then we take the average of those two. So we just divide it by 2. And same thing for the x and the y coordinates. That gives us the center of the split. For some reason that I haven't completely understood yet, I need to rotate the split vector by 90 degrees. Not sure why, but this actually fixes the issue, so that's fine. And then I create 2 arrays, one with the vertices that are going to go on the left, and one with the ones that are going to go on the right side of the laser, or the split. And then I iterate over all the vertices that are in the fixture we got. So yeah, we get the actual polygon from the fixture, and then we get the vertices from the polygon. And then for every vertex, we do this little loop right here. And this basically figures out if they are on the left side or on the right side of the cut. And then this is just debug rendering to make sure that we've decided they are on the correct side. And then this is where we gave up last week, because adding these in will cause issues that I will show you. Hello, Farutsky. Actually, when I think about it, I need to have my headphones on in case somebody subscribes. I want to be rude and miss that. Which I might already have. I'm sorry if I did. Anyway, this stuff won't work because I'll enable them and you can see how crazy this gets. Like, so far so good, right? So I can slice this, boom. It's immediately obvious that this didn't work the way it should have. So if I try and go over here and bounce this guy around a little bit, actually I can do that. See, one of them actually ended up being correct, I think. Yeah, that was mostly out of just luck. This one is just destroyed. Sometimes it will actually, you see, I can't even collide with it. Sometimes it will actually throw an error, and sometimes it won't. Try this one here. That is really bad. That's not the correct way of splitting it. So what happens is that, oh, I should have set up MS Paint beforehand. Oh well, we'll do it now. So the asteroid, right? We generate it basically like this: boom, 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 boom. And this gives us a bunch of vertices that are numbered, and they need to be numbered in counterclockwise order, if I remember correctly. So it will be like this vertex here will be 0, this will be 1, this will be 2, 3, and this one will be 4. So 5 vertices altogether. Oh, sorry, 6 vertices altogether. Now, say we slice this guy along this axis here. Boom. So now we iterate over these vertices, and we start at 0. So 0 is going to go, and we have our two lists over here. So this will be the left list, and this will be the right list. So we start at 0. So 0 goes on the left. 1 also goes on the left. 2 goes on the right. 3 goes on the right. 4 goes on the right. And 5. You can still tweet me to make these things pop up on my screen, by the way. Did you see how that just went away when I went to click it? That's annoying. Anyway, and this is all fine. Like 0, 1, 2, these are actually in counterclockwise order. 0, 1, 5, 0, 1, 5. That is counterclockwise. It's a little messed up counterclockwise, but nevertheless. Can I? No, damn it. I can do that. So I can, now I want to add in the special vertices, right? So we do all this and we have figured out the local entry point and the local exit point. These vertices also need to be added to the new polygons. So these guys will be happening like right here and right here. We can name these, let's name them A, and this guy can be B. So what I'm doing here is for the left side, I'm adding the exit point and the entry point. Let's say that this is the entry. You can do that. No, like that. That's the worst arrow. So this would be the entry point. So for the left side, I am adding the exit first and then the entry point. So I would go B, A, and on this side I would go A, B. So if we do this like manually, so there'll be 0, so this one, 1, okay, still cool, 5, still cool, still going counterclockwise, and then it goes down here, which makes no sense at all, and even worse, it goes up here. So that would give you the crisscross kind of thing. So this is obviously no good. We can't do it this way. And it doesn't really matter right now which one's the entry point and which one's the exit point. It's wrong either way, but I have actually figured out a way to do this. So one thing you could do is you could sort the vertices using some kind of funky number. But then I have to figure out, like all these guys are the original vertices are easy to sort because I know which order they were in originally. I don't even need to sort them. They're already in a good order. The tricky part is that I would need to figure out where these guys, A and B, end up in the order of vertices. So the thing I have figured out that I'm going to do is as I'm iterating these, like I'm going from 1 to 0 to 2, I will know, because all of these guys on this side will have, I'm calculating something called the dot product, are going to have a positive dot product or a negative dot product, and all these guys are going to have the other value. So if all of these are positive, these are going to be all negative. And I will know when I transition from the positive side to the negative side and vice versa. So that's what we're going to do. We're going to keep track of the dot product that we had before, and if it's different from the dot product that we have now, we're going to add in these extra vertices there. Just let me look at my little notes here so I don't lie to you too much. Right. So outside of this loop, we're going to save the dot product we had before. It's going to be a float, and the thing is, we don't want to do this the first time around. Like for the first vertex we get to, we're not going to have a value at all. So either we could keep a counter here so we know that we're on the first iteration, or we could just give this a special value so we know that we're on the first iteration. I am going to do, I'm going to set this to a number, which is like the crazy spare value that you can have on floats. Is that actually, yeah, it's a float, so I don't even need to do that. This is a funky number. You don't want to do math with this, but it's useful for this type of stuff. And this is also what you get if you like try division by 0 or something. You will get not a number. That's the value. Then I'm going to rearrange my windows a little bit. So in here, I can check, first of all, if, and not a number is doubly funky because it's not like I can't do this. I can't check if last dot is equal to math nan. This will always return false because not a number isn't, you can't use that for comparison because it's like special and weird. So even though this would be true, like last dot is, I set it to not a number just now, that would always return false. So I have to do math is not a number, last dot. So if that is not true, we know we are dealing with a new or not the first vertex basically. And then here we can set last dot to dot. So it does all that. It does the math. Actually, let's do it last. Just so we'll go through this. This will be not a number. It goes past that. It will set this value here into this one, and that one will stay until we get into the next iteration of that loop. Excuse me while I turn off crap. Okay, here we go. So if mat is not a number, or if last dot is not a number, we know we're on the first thing. Then we can do the comparison bit, which is the interesting part, right? So now we only really care if the dot product was negative before and it's positive now. Like if it's a different sign, that's all we care about. So we can do something like if dot is smaller than 0. Hey, someone subscribed. Welcome. Krabba, maybe. I don't know if that's Swedish, might be. So if dot is smaller than 0 and last dot is bigger than 0, we know we've changed sides, right? Or actually, let's do, well, it doesn't really matter. But yeah, we can do that. So if dot is smaller than 0, this is going to be true or false. And we don't really care which one's which, as long as they are not the same. Someone subscribed again. Sheepolution! Welcome to the club. Oh my god, even more. Helkios! Also welcome. So this should trigger when we're switching sides. I think. So then we can go, so if dot is bigger than 0, we can say that we entered left side. And if not, which means we're basically on the other side, we can just say that we entered right side. And then we can disable these guys down here. We're not going to need those for a little while. And we'll give this a try. Split this, and now remember to keep an eye on the trace window down here. Boom. Oh, nothing. Oh, right, it's because I'm running in release mode. Debug. Hey, someone subscribed again. Who are you, mystery subscriber? I can't convert that to decimal in my head, but OXBF34, welcome. So now we're going to split this guy. Boom. So we entered the left side. And this is another thing that I figured would happen. Entered, found one hits, entered right side, entered left side. Depending on where the cut happens, it might enter. It's always going to enter at least one side, but it might not enter both sides. If we go back to paint. So for this, it's going to start on this side. It's going to go this way, and it's going to enter. This is going to be the left side, I think. Right, this is going to start here, and it's going to go here, and it's going to go here, and it's, oh my god, I entered the right side. It's going to go here, and it's going to go here, and it's going to enter the left side. So it might do this. But if you suppose that the cut happened along some other axis, like here, it's going to start on the left side, like 1 or 0, 1, 2, and it's going to enter the other side, and it's going to go out, and it's going to be done. It's never going to cross over again. So that's also something we need to be checking for. Someone's asking in the chat what physics engine I'm using. It's Box2D. I hear that there are better ones for Hexa use, but I've used Box2D in the past, so I have at least some idea what I'm doing when I'm using Box2D. But once we enter, if we enter the left side, I suppose we could also enter the left side twice. No, we can't, so that's fine. But when we enter the left side, we want to, let's keep that. So when we enter the left side, say down here, we want to add the exit. No, we want to add the entrance and then the exit, or the other way around. I can't remember, because that would put them in the correct order. So like once we pass here, we want to add this guy first, and then that guy, and then all of these in order. So it's going to be counterclockwise, right? So let's just try something here. On the left side, we want to push the local. Let's try that order. And I gotta call out who subscribed. No, I was too slow. I didn't see you. Who are you, mystery subscriber? And I suppose on the other side, we just do it the other way around. I think that would make sense. Let's try that and see what happens. Whoops, assertion failed. That's not good. What did I do? Okay, let's try it again. That seemed to be fine. I don't. Once it fails in assert, it's might not ever recover. So it enters the right side, but it never enters the left side. Interesting. Hey, it worked. So for that guy, found 0 hits? What? Oh, well, I mean, I know this is broken right now, so I just gotta deal with that. Oh, right. Good call, real fiddly. Very good call. That would make perfect sense. That's what I get for copying and pasting too much. It's a immediate punishment. So this side was fine. This side, not so fine. Actually lucked out and got them in the correct order. This one was perfectly fine. Like, that's the way I want it to go. That's just beautiful. Yeah, if I do them that way, it's fine, because I think it starts... I'm not entirely sure where the first vertex is going to be. But I think if I slice it that way, that also worked. That didn't work. So if we clear this output right here and we slice this one, boom. It entered both the left side and the right side, so that one's going to be fine. This one only entered the left side. So what I basically need to do is I need to keep track if it actually entered either of the sides. And if it didn't, just add them in afterwards. I think that should be fine. So yeah, and the loop ends here. So I could save those guys. So if we didn't enter left, we want to push these guys on there. And doing it this way should be fine, because that means we're on the intersection anyway. If we didn't enter right, same thing. These guys up here. Whoops. I think this is it. It's gonna work now. Famous last words. We'll see. I'm so excited. I love how the red line actually obscures the cut so you can't see. Just, would you look at that? That is just beautiful. Slice them again. No! What happened now? Assertion failed. Something with the mass. on the right asteroid. Haha, can't do them in the same order. Gotta be entry, exit, yeah. I'm very excited about this. This is gonna be cool. Slice! And one thing that's what I'm using right now, like back when we started, I added so I can click them to make them spin. Just look at that. Pretty rad. Whoops. What happened now? Oh, I started inside? What's going on here? Oh, right. I can fix this. So I just gotta check if hit is null. And we just return 1, I think. Should fix that. Boom. That's just beautiful. So many little pieces. I'm very excited about this. I mean, this is fun already. So one thing that's going to be a problem with this is going to be like super tiny little. They're not even physics objects. They're like particles, like little dots. Like this guy right here, like 4 pixels wide, 2 pixels tall. We don't want those, so we're going to have to add some type of code to detect when they're like too small. And just disregard them. Like the player wouldn't even notice if those went away, and we don't really need them for anything. I like that the frame rate is like 50-50, really good. 50-50, terrible. Or 50. I can't talk. This is great. Actually, you know what? I'm gonna try something. Did you just see me slice a hole through the world? I don't like this physics simulation. I'm leaving. Whee! That's just glorious. And I think the like having the laser either end or start inside something is like also not crashing things anymore. So that's good. One thing I want to do now is when I slice them, nothing really happens. It just stays there. Like if I do it with these, like the fixed asteroids, I can go like that. Zip. Nothing happens. You can't even tell that they got sliced. So I'm going to add a little bit of force to like push them apart because it's going to look cool. And I mean, if something, whatever laser or whatever it is, was powerful enough to actually slice it apart, I guess it would also add some force to like push them apart. So let's get rid of this trace stuff. We don't need that. So and down here we have some duplicated code too. That's not super good. Might have to deal with that. It's within reason still, but I don't particularly like it. And we already, like last week, we did the stuff where we are actually setting the position and the angle velocity and the linear velocity of the previous asteroid. So if I do, and you've seen this already, but so if I do like this, come on, I shove it out of the way and I slice it as it's moving, both of the pieces will continue moving along in the same direction the original piece did. One thing that doesn't really work the way it's supposed to is if I make something spin. Maybe that's a little bit too much. Like this guy right here. If I slice it now, no. Like here. You see that it goes from spinning like this to the pieces spinning individually like that, and it doesn't really make sense because they would like fly away and like rotate differently. But I think adding the split velocity thing is going to make that a lot better. So what we want to do now, because all of this is working now, that's very good. We should probably commit this into the little source control. So what we're going to do now is that we're going to use, we have this thing I call something like split vector or something like that. Yeah, split vector. We have that guy. We can use that because that is the direction of the cut inside of the asteroid. We can use that to apply a force to the pieces that we've made. So I think we're going to leave this as is, and then for the left asteroid, we're going to do like, let's call it split force. And then we got to figure out, because now they have, we got to get that inside of the coordinate system of that new asteroid. I think that those are going to be the same as this asteroid. We can do it that way anyway. So left asteroid. Oh, right. No. So when if I want to apply, like if I go left asteroid, apply force, I can never remember if it's force or impulse. And I want to apply my split force here. The thing is, the force that is applied is in world space. Apply force at a world point. So we got to go from the local point back into the world space. So like up here, the cuts and all that stuff is coming in world space, and then we get them in local space. So now we're going to go back again into world space. So we do left asteroid, get world point, I think. Split vector. No, that makes no sense. I know the point. I want to get the vector. So the direction is also going to be in. And I suppose I want to apply this at the center. So I can do left asteroid, get world point, and then I have the split center. So this will apply the split force at the center of the split. So it's going to be, if we look at MS Paint, like it's going to be right here, which I think is a reasonable place to apply it. Right. Let's try that. So this is going to be only for the left side. Let's just disable the right side right now so we don't have any confusion of which one's which. That's a pretty tiny force if it's applying at all. Let's try making it really strong. Multiply by 100. Something's happening. It's also going the wrong way. It's going the correct angle, but the wrong direction. So I think we can just do that. Haha, that's awesome. Smack. The big one. I think that works. And then we do the same thing for the right side. And now we're nearing the point where this might make sense to split up into some kind of function. So again, split force. This time we're going to go right asteroid, get the world vector of the split vector. And since this one's on the other side, we don't multiply by negative. And then on the right asteroid, we apply the split force like that. That should work. Geez, this is taking a long time. Boom. Boom. I'm gonna just shove them apart a little bit so we can appreciate the glory of this splitting. That's super cool. Kind of looks like one side isn't really moving as much. Oh, it is. I want to disable these debug drawing things. I think there's more of them somewhere. Debug render, go away. And I think I'm also going to make the laser a little bit thinner so we can see what's going on. Smack. It's important to make good sound effects. This is super rad. Rad, rad, rad. Full screen. Come on, here we go. Can I? Whoops. I can't do anything. I'm going to set the quality to low so we can actually have some frame rate in full screen. This is still sluggish, but it will work. Slice, slice, slice. So one thing it does right now is that it applies a fixed power impulse to things, both when I spin them. So if I click this small asteroid up here, it's going to spin really fast. You can almost not tell that it's spinning because it's like rotating like 90 degrees per frame or something, like a lot. So if I click this big one, it's going to spin a lot slower because I'm applying, like this one's much heavier. So the same amount of force is going to make this one spin a lot less. You can click the player, make him spin like crazy. And this tiny one here, if I click it, it's going to spin also. Like it's hard to tell exactly how fast it's spinning. The same thing is happening when I slice something. So if I do this big one, they're going to move apart, but not that much. If I do this small one, it's just going to fly apart. So that's also something we're going to need to deal with. It's not going to be realistic necessarily, but this is a video game, so we don't care about that. Because I want them to fly apart at reasonable speed, disregarding the size. Like that type of movement is probably preferable to like that, because that is a little bit too much. It's still asteroids, like you still want to maintain that they are heavy. And I think we can make that work by actually calculating how heavy they are and scaling the force we're applying by that. I'm pretty stoked by this. Maybe I should just cancel all development for tonight and just slice things. You can do like the salami style slice here, just like a bunch of thin. I'm going to slice the edge of the world soon. Come on. There we go. And this actually, like Vox2D is pretty good. This keeps on trucking pretty well for a long time. I can keep, I mean, it's running in debug mode in full screen on my computer that is streaming, and it's still keeping up pretty well. So Vox2D is cool. I like Vox2D. I also think I have a plan for it to go with the design of this. But I don't think I'm going to tell you guys just yet. So that's cool. Let's actually get that committed into version control. This is totally 2 commits. So this is 1 commit. Stage hunk. Stage hunk. Split forces, and the rest is another commit. This is disabled debug render. It is pretty much Fruit Ninja in space right now, but the slicing is going to be attached to the ship in the future. It's just on the mouse right now because it's more practical that way. So yeah, we're gonna have to do some housekeeping now, I think, and fix this up because this is a mess right now. I'm gonna keep the debug render around for a little while. I'm not gonna remove that, but I am going to split this up into 2 functions. So let's call this CreateAsteroid. I don't know. And we'll see. And we're gonna need to know which side it is. Is left, maybe? We're gonna move this little code into here, and all the stuff that's related to the left asteroid is gonna go in here. And then we can... Oh, who is it? Inky String. Welcome aboard. And we don't need this stuff. Why did I name it Peace? That makes no sense. I don't know what to name this function. Create subslice. No, that's also terrible. This is important stuff. It uses a CreateAsteroid. Let's just call it CreateAsteroid. That's good enough for our purposes. You can rename it later if you don't like it. This is going to be like that. CreateAsteroid, right, and that is going to be false. And now this can't be named left asteroid anymore. It just needs to be asteroid. And vertices can't be... Actually, that's probably only used in one spot. So like that. Sets the position and the angle. And then we're going to need the body. What else do we need? We're going to need the split vector. Will this compile? Did I forget to rename something? Unknown identifier, split center. Cool. Will it work? It did. Oh, but they're going the same way. So for this, I can do, let's do this. This is funky. So if left is left, it's going to be -1. No, it's going to be 1. I don't know if this is good, like a nice way of doing it or not, but it saves one line. It saves more lines actually. So this little thing right here, if this is true, this is what it will evaluate to. If it's false, it's going to be this. So essentially, if it's the left one, it will multiply 100 by -1, making it -100. If it's not, it's going to stay at 100. Did it work? Yes. I think so. They are going different directions. This also helps a ton with the directional stuff being weird. Which is nice. Maybe we can figure out asteroid get mass. Here we go. Get the total mass of the body. Usually in kilograms. That's helpful. I have no idea how heavy they would be. So if we do a big one, and we are in release mode. We can't be in release mode. Try this guy. How big were they? 32 kilos. That's a respectable weight for an asteroid. So these are going to be really heavy, right? 40 something. I have no idea how the force scales with the mass. None at all. Would a 1 kilo object go 10 times as far as a 10 kilo object? I don't know. Suppose it would. If we work on that assumption, then we can actually change this up a little bit. So we do split power maybe. That's going to be asteroid get mass through, let's say that the default asteroid is going to be 30 weight units. So a big one is going to be, it's going to get a bigger power. And then we can actually do if is left split power. Let's do that. And let's keep the force at 100 for now. See what that does. That seems fine. It's maybe a little bit weak right now. Let's try the big one. annoying because it's stuck in the... That's perfect. I kind of like that. Maybe a little bit more force. 120. It's hard to tell when they're stuck inside as well. Yeah, that's good. And now we can actually, let's move it into here and we'll make a static public. Why are these not inline? I don't know. I'm not even sure I'm using these vars right now. Especially not these two. I don't think I'm using these two. Oh well, I'll delete them some other time. Now we're going to do static public inline var, and this is going to be called laser split force. And that is going to be float. That is going to be 130, right? 120. So settings, laser split force. Means we don't have to remember exactly where this is applied or what that number is or whatever. We could just go to the settings when we want to tweak that. I think that's the only value that we have that we need to be configurable right now. The player controls are awful right now, so I'm going to have to redo those, but those should probably also go in the config eventually. The question is, what should we do now? Wonder, I want to make the rotation a little bit nicer as well. So like this angular velocity thing. Apply torque. Can I get, no. That seems like hard work. I'm not going to do that. Because it's going to be, it's going to be tricky. We'll see. I'm going to run the C++ version just to bask in the glory that is my, that is R, I don't know. Bask in the glory of the physics. Let's put it that way. If and when it compiles. Here we go. This runs so much smoother. I don't think you can tell because I'm streaming at such a low frame rate, but this runs way, way smoother. Slice. Wonder what a smart way of figuring out if they're too small would be. I'm not sure I would need it, but maybe that's a good, good little thing to do right now. I suppose I could do a check here. Because there are two different things that could happen, right? We could have an asteroid that is like something that's like, let's say this is like a normal sized asteroid, like a big thing. So say we have an asteroid that's like that. That is obviously too small. We don't want that. We could also have an asteroid that's like, and this is going to be small on every axis, right? We could also have like a super long, really, really thin asteroid. I can't draw it thin enough, but I mean, these are very possible to make right now and are in many ways just worse. I don't know why I stopped talking while it's compiling, but it's just this impulse I have. So like these guys right here, that's going to be pretty easy to detect. I could just check the mass, or even it's entirely possible that Box2D has a thing for me to check the area. So that's going to be, those are going to be easy to get rid of. The ones that are going to be harder are these guys. This might actually be a valid one still, but like I can do these almost infinitely thin. This made my mouse run out of battery trying to do that. That's annoying. But yeah, slicing them like that that's going to be more of a problem, I think. And these guys, someone, Punk Emma, is suggesting in the chat that I could find the volume and remove them. But the ones that are going to be really thin and long might have a larger volume. Come on, mouse, you can do it. Maybe not. It would be very helpful to have a mouse for the rest of the stream. Here we go. So, if I do this guy right here. Super thin, like these guys, super annoying. They are not our friends at all. And they're going to be really in the way too, and they're going to mess up the physics stuff, because worst case scenario with these guys, if you go fast enough, you can sort of get stuck inside and they're going to be annoying. Sea Bear Wallace, welcome to the club. So I think we're going to have to do something different than just checking for volume if we want to do it properly. So I'm thinking that we loop over the vertices, and if they are too close to each other, we remove them, as someone suggested just now in the chat. Yes, Swiss cheese. So we check the distance between the vertices, like these two guys right here are gonna be super close, so we don't even need two vertices there. So I'm just gonna remove one of them, and that's gonna be fine because it's gonna turn into a triangle. But once we get down here, we're gonna remove another one, and then it's gonna just be two vertices left, and then it's not a valid shape anymore, and we can just discard it. Which would fix both these and these, because these would be either one or two vertices remaining, and that would be like they would be discarded anyway. So, and we probably need this anyway if something goes wrong. If vertices length is smaller than 3, we just return. There's nothing we can do. And now we are going to do something like, do I need to compare? I just need to compare it to the previous vertex, right? So I can do something like this for I in vertices length. So previous current is going to be vertices I. That's pretty easy. Previous, God, I can't spell, is going to be vertices I minus 1. But this is not going to work for 0. So we need to do some voodoo trickery with this. And now we're going to use my best friend modulus vertices length. I think that should work. We'll see. Now I can do this B2 vec have a thing for. It does. That's very helpful. So I can do current and I can do previous. And if distance is less than an arbitrarily set threshold. Hey, Coastwise, welcome to the club. So if D is smaller than, I have no idea how big these asteroids are. Let's take a look at the code for making them. Generate asteroid. Blah, 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 blah. Radius is not there. Handle, enter frame. Here we go. Radius. Radius of 30 plus, so they're between 30 and 60. Kind of. So if they're less than 5 apart, we don't want that. So then we can, actually this gives us another set of problems. We can't iterate. So now we come to another funny programming issue. If I'm going forward in this list and I'm removing stuff as I'm going forward, that's going to cause a ton of pain. So we're actually going to have to iterate in reverse. But that's fine. For I is 0. No, it's not. It is vertices length, and then we do while I minus minus is bigger than or equal to 0. That should be fine. This is probably not going to work on the first try. If D is less than 5, we want to do vertices remove. No, can't do remove. Splice. We want to remove the thing at that index, and we want to remove one of them. This is going to be interesting. If this runs at all. Nope. The drawback, like the Windows versions, it's nice because it's fast, but the way I have set it up now is that it won't give me any debug information whatsoever. So let's go back to the Flash version. Someone's upset. So while I minus minus is bigger than or equal to 0. It went past 0. That's not good. That's not good either. It just discarded all of the vertices everywhere. Let's trace that and see what it's doing. Oh wow, these are way smaller than I thought they would be. Right, it's because it's in the physics coordinate system, so it's actually 30 times smaller. So these are all like 1, 2, 3 apart. Let's set it at 0.25. See what that does. Now someone else is upset. What is I right now? I is 0. I bet you it's this one. Null? I wonder if I need to go like that. This is a little bit overkill for my current purposes, but well, it's still not working. Oh well, let's just do it manually then. So if I is equal to 0, it is going to be vertices length -1, and if it's not, it's just going to be I -1. It should be fine. That worked. That also worked. Let's try a smaller one. Try a corner. Oof, just went away. Oh, it went away again. Oh my goodness. So maybe that's kind of a problem, that they actually just go away, but maybe not. Maybe that's fine. It's going to look a lot less crazy if I add some particles to it. I think I could set the threshold. What happened? Oh, it was removing. So that's another. I don't know if it's a good thing or a bad thing. Like if I slice this corner right here. Who's subscribing? Danny the Cake. Welcome to the stream. So this one's perfect. So if I cut this corner off and I make the triangle small enough, that didn't work the way I wanted it to. So if I cut this corner off, it should be a flat corner there, right? But it's not. It's actually discarding that vertex and just moving that little thing in. I suppose I could fix that too and just average those two. I mean, if we're going to do this, we might as well do it properly. So then vertices, or actually we can do it with current x. We're going to add the position of the previous one. No, for the previous one, because that's the one that's going to stay. The current one is the one that's going to get removed. So for the previous one, we add the position of the current. Same thing for the y-axis. And then, actually that's an ugly way of doing it. Let's do it this way. Previous x, this is a y, and then we average these two. That's going to be nicer. Just this little tiny touch, almost free, performance-wise. So we might as well do it. That does look nicer. I think it's correct. It just looks like the corner gets bumped a little bit. That's fine. It's going to look a little bit weird if I get like a super long triangle and I do that. That's fine too. If I get some particles on top of that, it's going to be perfectly fine. And I mean, if it turns out I actually want it to behave the other way, it's going to be easy to just remove this. I suppose this is maybe the really, yeah, I guess it can still, like, that's one thing I'm not taking into consideration at all. Snigglepiss. I don't know what that means. Welcome to the stream anyway. If I do a really like thin, long triangle, that's still going to be a problem. But well, it's kind of too early in the process to worry too much about this stuff. I mean, if it's fine performance-wise, can't see why we shouldn't have it. I'm happy with that. Let's commit that. Hello, Arc Games. You're late. We want that. Right, let's just do all of it. So this is smarter split. Force takes object mass into account, discards vertices that are too close, and polygons with too few words. Yeah. We are... wow, this took way longer than I thought it would. I was hoping we could have time to start something new today. What, you have some good questions in the chat. Let's scroll back a little bit. Someone asked that, oh, this is a long time ago, like 15 minutes ago. Someone asked what the move from ActionScript 3 to Haxi was like. It's super smooth. Haxi is basically ActionScript with more stuff. So as long as if you're comfortable with ActionScript, it will take you like a week to get up and running with Haxi, the programming language. There are some other things you need to learn, but if you use OpenFL, like I do, it makes the transition really smooth for the programming language. If you're using the like Flash authoring a lot, it's going to make things a little bit more complicated. I didn't do that. I've been using like pure code projects for a long time, so it was a really smooth transition for me. I just went from one type of programming to another. I actually stupidly I started out trying to port something to Haxi, which I wouldn't recommend. I would recommend trying to make like a little small project first. Something like, doesn't even need to be big, like a 1, 2, 3 day little thing. Is way smarter than trying to port something directly. Am I using Git or Mercurial? I am using Git because I don't know. I started using that a long time ago, and I have stuck with it. I really like the branching, like the distributed version control philosophy. I guess the branching isn't as much the distributed version control, but like modern, like having actual branches that work, that you can merge and deal with, is really helpful for my workflow. Because a lot of the time I will be like, oh, I want to add this feature and I don't know if it's going to work. And I make a branch and I can continuously commit as I'm working, but I haven't really promised that I'm going to do something. And then I could just go back and be like, okay, this wasn't a good idea at all. Like, you just ignore those commits for a while, like keep them around. It saves a lot of copy pasting crap for me, which I really, really enjoy. I don't know. What do you think? Shatters, what do you think we should do now? I actually don't know. And I can only stream for about 20 more minutes. Then I got to go do some stuff. I suppose we need to deal with rendering at some point or another. This is just the debug render from Box2D, which is not game graphics it does not make. I wonder. I wonder what the asteroids would look like if I did them with a whole bunch more sides on them. So like num sides, let's do from 16 to, this might look really crazy. First problem, they are not convex anymore, which is causing all kinds of pains. So if I tweak this down a little bit, still not doing it. Now they're basically going to be spheres. Boring old spheres. That does work really well, though. That's cool. So we know that works. This has to be like my favorite thing. Boom. Let me out of here. Bye, guys. I'm leaving. Whee! That's super cool. Yeah, at some point we might have to do so you can deal with composite shapes. Because right now they can only be one fixture, and a fixture in Box 2D needs to be a convex shape. So we can't do like the spiky asteroids. They need to be less complicated shapes. But let's go back on that. What did I change now? Whoops. I'm not even going to bother with actually figuring out what that was. I'm just going to look at the version control. What did I do? Oh, right. Revert. Here we go. Back to the spiky old asteroids. And once we do actual graphics for this, we can because this is just going to be the logical appearance of the asteroids. It doesn't necessarily need to be the visual appearance. We can round off the corners a little bit and make them look nicer somehow. Kind of want to get started on the flocking thing. To like, because that's something I was talking about last week, having code out. Nice work with Haxy stuff. Something I was talking about last week is like when you start out, all the asteroids are like bunched up in the center like this, which is just because I'm spawning them super lazily. But as soon as you touch them, they go just flying off into eternity. These amazing asteroid shapes, and they're just going to keep going that way because there's no friction in this. I mean, we could add friction, but it's going to be a problem eventually anyway, because you're going to be mostly just shoving them away. So what I was thinking is I do a flocking thing, and flocking is just this name for between all objects that you are near, you calculate like, okay, how far is this? let's not do that color. Let's do like how far is this distance here? And then if you're too far away, let's keep it that color. If you're too far away, you move closer. And if you're too close, you move further away, just like distance-wise. And once you start doing that towards every object that you are near, and the objects also in your vicinity are doing the same thing, you get this really cool like emergent behavior, which means that since everything's trying to stay at a fixed distance, you get this, it looks like a flock of birds. I wonder if there's like a YouTube video or something I can show. Whoops. And this discovery was a big deal in computer simulation once upon a time, for a really long time ago. Here's some random dude's Boyd's simulation. I have no idea what's going on here. Oh, this is awful quality. You're fired, random person. So here's one. This one's in 3D, but it doesn't really matter that much. So just the fact that they are trying to keep the same distance from each other makes them go in this cool like flocking behavior. They're like a flock of birds, and then this guy probably has added predators and stuff. And the Boyds actually have a few more constraints. They're not only trying to keep the distance fixed, they're trying to move to the center of the flock. That's maybe something we want to use for our asteroids, just to keep them sort of centered so not everything just flies away. It's not going to be a huge problem for us, but it might be. And Boyds are also trying to match the average direction of the flock. So everything around it tries to go the same direction, which makes it like meander around in a very organic fashion, because it doesn't really have a plan for where it's going. It's just trying to go the same direction as everyone else, but everyone else is also trying to like compensate for where they're going by like avoiding the neighbors and stuff. So you get this like super cool motion thing going. This has started to like oscillate around the center now, probably, but still, it's pretty simple math behind it. It's just, it gets complicated when you have tons and tons of agents in it, but it should be fine because we don't even need to do it all the times. If we do it like periodically for everything, it should not be a problem. And we're not going to have that many asteroids either. It's just going to be like, I actually don't know what like a large amount of asteroids would look like. How many are these? This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. Is there a way I can keep track of that? Well, I'm going to do like 300 or something. Shouldn't be a problem, and that's going to be a lot of asteroid bits. That should be fine. So I don't think we're going to start that right now. I think this is going to be actually the end of the stream for today. Let's switch it to the full screen mode. Oh, I'm super low, and that's better. So yeah, that's going to be the end of the stream for today. There might be some cool stuff happening next week with the stream. There might be more streaming next week. We'll see. I'll keep you guys posted, and at the very least, I'm going to be here at 4 in a week and streaming. I might start earlier, or that might be in 2 weeks. We'll see. I've got some cool stuff coming up. yeah, I think that's all I have to add for today. If you have any questions, oops, sorry about that. If you have any questions, you can hit me up on Twitter. You can just ask, just like send me a message on Twitch. I'll answer, and I'll hang around the chat for a little bit after the stream. If you have anything you want to know, and this video will be on YouTube as well shortly. And thank you so much for hanging out with me. You've been great as always. Thanks, guys.